Hi everyone, my name is Aria, and I work alongside Whitroy as an electrical tutor. Before we begin, I want to make something clear about this audiobook. This is not a word-for-word reading of ASNZS 3000, 2018. The standard itself must always be read and followed exactly when you are doing electrical work or preparing for EWRB exam. What this audiobook does is take the key ideas from the standard and explain them in simple, spoken language, the kind of language you can listen to while driving, working, or revising. It helps you understand what the clauses mean, why the rules exist, and how they apply in real installations. So think of this as a learning companion, not a replacement for the actual standard. Alright, let's get started. Today we move into Section 4 of ASNZS 3000. This section focuses on the selection and installation of electrical equipment. It explains how electrical equipment must be chosen, installed, protected, connected, and controlled so it operates safely under normal use and under fault conditions. Throughout this section, we look at how equipment is protected against heat, mechanical damage, fire, and electric shock, and how correct installation helps prevent harm to people, property, and the electrical installation itself. Everything in this section is about making sure electrical equipment is fit for purpose, suitable for its environment, and installed in a way that keeps everyone safe. Clause 4.1, General. This clause sets the scene for Section 4 and explains that this part of ASNZS 3000 is about the minimum requirements for selecting and installing electrical equipment so the installation meets the safety goals of Part 1 of the standard. It covers equipment such as appliances and accessories and focuses on making sure everything chosen and installed is suitable for its intended use. Clause 4.1.1, Application. This clause explains that the section applies to the selection and installation of electrical equipment, including appliances and accessories, and that the goal is to meet the overall safety requirements of the standard, not just to make equipment work but to make sure it works safely for people and property. Clause 4.1.2, Selection and Installation. This clause explains that electrical equipment must be chosen and installed so it works properly under the conditions it is expected to face, does not cause harmful effects to the electrical installation, operates safely when correctly assembled and connected to the supply, and does not create danger from electric shock, fire, high temperature, or physical injury during reasonably expected conditions such as overloads, abnormal operation, or faults. It also explains that equipment must be installed to meet the requirements of this section as well as the manufacturer's instructions, and that some equipment must comply with nominated Australian or New Zealand standards or other relevant standards. The clause then explains that the section covers matters such as external influences and environmental conditions, harmful effects on the installation and supply, protection against thermal effects, methods of connection, installation of socket outlets and lighting and heating equipment, electricity converters including UPS systems, control and protection of motors, transformers, capacitors, equipment containing liquid dielectrics, and smoke alarms and fire detectors. The notes explain that some equipment may be remotely switched, meaning care is needed when working on it because it could become live without warning, that clearances are required near cooking surfaces, that special rules apply in rooms with baths or showers, and that in New Zealand attention is drawn to NZEC P55 for wiring and fittings near conductive thermal insulation. Clause 4.1.3, External Influences. This clause explains that all electrical equipment must have characteristics suited to the conditions it is likely to be exposed to so it will function properly at its installed location. It explains that this suitability may come from the equipment's own design and construction or from additional protective measures provided as part of the installation, as long as those measures do not interfere with correct operation. The clause then explains that damage can result from many external influences, including mechanical damage, weather such as rain, snow, ice and sunlight, water from splashing or high humidity, plant growth, animals, excessive dampness, corrosive fumes or liquids, galvanic action, dust or foreign objects, steam, oil, temperature extremes, solar radiation, explosive atmospheres, vibration, and seismic activity such as earthquakes. The notes explain that IP classifications describe protection against water and solid objects, that purpose-made drainage features can be used without reducing protection, that drilling holes can destroy the IP rating, that some accessories without a marked degree of protection may still be considered protected when installed in sheltered locations, that accessories installed outside those sheltered areas must meet a minimum IP33, and that some specific enclosures in metering equipment have stated exceptions. Clause 4.1.4 Adverse Effects and Interference. This clause explains that electrical equipment must be selected so that during normal operation, including switching, it does not cause harmful effects to other equipment. It explains that issues to consider include power factor, excessive voltage fluctuation, severe distortion of current waveforms, and electromagnetic emission. Clause 4.1.5 Air Extraction Systems. This clause explains that air extraction systems can affect the safe operation of combustion appliances, including appliances in other rooms, and may create a risk of carbon monoxide poisoning. It advises that customers should have fluid combustion appliances tested by a competent person to confirm correct and safe operation. Clause 4.2 Protection against thermal effects. This clause explains that Section 4.2 is about managing heat produced by electrical equipment so that heat does not damage equipment, wiring, buildings, or create safety risks such as fire or burns during normal operation. Clause 4.2.1 General. This clause explains that electrical equipment must be selected and installed so that, when it is correctly installed and operating as intended, its temperature does not negatively affect the equipment itself, the electrical installation, or anything nearby, whether electrical or not. It explains that ventilation must be provided when needed so operating temperatures stay within the equipment's rated limits when heat is produced in normal use, and it reminds us that temperature can change how equipment performs or behaves, so this must be considered during selection and installation. Clause 4.2.2 Prevention of Fire Hazard. This clause introduces the need to prevent fire risks caused by electrical equipment. Clause 4.2.2.1 Installation of electrical equipment. This clause explains that electrical equipment must not be installed in a position where it could create a fire hazard. Clause 4.2.2.2 Storage of flammable materials. This clause explains that where an area may be used to store flammable materials, steps must be taken to prevent ignition from sparks or high temperatures, and it points out that special requirements apply in hazardous areas. Clause 4.2.2.3 Protection from high temperatures. This clause explains how fixed electrical equipment that can reach high temperatures must be managed so it does not create a fire risk. It explains that where surface temperatures could ignite nearby materials, the equipment must be mounted on or within materials that can tolerate the heat and do not easily conduct heat, or be screened from combustible building elements using suitable heat-resistant materials, or be mounted far enough away so heat does not cause damage, with supports that limit heat transfer and allow safe cooling. It also explains that where equipment produces radiant heat, it must be placed far enough away so nearby objects or building elements are not exposed to dangerous temperatures during normal operation. The notes explain that some building materials can slowly break down when exposed to heat over long periods, that many common electrical items are sources of high temperature, and that restricting heat dissipation can cause equipment itself to overheat. Clause 4.2.2.4 Emission of arcs or sparks. This clause explains that where permanently connected electrical equipment could emit arcs or sparks during normal service, it must be fully enclosed in arc-resistant material, or screened from nearby building elements using arc-resistant material, or mounted far enough away to allow arcs or sparks to safely extinguish without causing damage. Clause 4.2.2.5 Electrical equipment enclosures. This clause explains that enclosures must be able to withstand the highest temperatures likely to be produced by the equipment, and that flammable or easily combustible materials must not be used to build those enclosures. Clause 4.2.2.6 Prevention of spread of fire. This clause explains that switches, socket outlets, and similar accessories must be arranged so there is sufficient separation from openings in fire-rated walls, ceilings, or floors, and that openings made for electrical equipment must not weaken fire-rated barriers beyond the permitted extent. Clause 4.2.2.7, Thermal insulation, New Zealand only. This clause explains that in New Zealand domestic installations, appliances and accessories must not be installed on thermal insulation in ceilings, walls, or underfloors, and this applies even if insulation is not present at the time but may be added later. Clause 4.2.3, Protection against burns. This clause explains that accessible parts of electrical equipment within arm's reach must not reach temperatures that could cause burns under normal conditions, and that any accessible part of the installation that could exceed safe temperature limits, even briefly, must be guarded to prevent accidental contact. It also explains that some equipment is exempt where temperature limits are controlled by an appropriate standard, and that items such as lamps are excluded from this requirement. Clause 4.3, Connection of electrical equipment. This clause introduces the rules for how electrical equipment is to be connected to installation wiring. Clause 4.3.1, General. This clause explains that electrical equipment may be connected to installation wiring using the permitted connection methods, and that the point of connection must be as close as practical to the equipment and protected from mechanical damage or interference. It explains that wiring forming part of the equipment itself is considered equipment wiring and must comply with the relevant product standard, or ASNZS 3100 where no product standard exists, and that certain accessories must not be used where the connection point is not readily accessible. Clause 4.3.2, Direct connection. This clause introduces direct connection methods. Clause 4.3.2.1, General. This clause explains that installation wiring may be directly connected to terminals provided on the equipment for that purpose. Clause 4.3.2.2, Installation coupler. This clause explains that an installation coupler meeting ASNZS 61535 is suitable for connecting cables, including flexible and rigid types. It explains that installation couplers are intended for permanent connections between wiring sections and are treated like junction boxes, and that they require deliberate action to disconnect and are not intended to be used under load or as socket outlets. Clause 4.3.3, Installation wiring connected by an installation coupler or couplers. This clause introduces requirements for wiring connected using installation couplers. Clause 4.3.3.1, General. This clause explains that cords or cables connected by an installation coupler must be heavy-duty sheathed types suitable for the protective device, adequately protected and installed to reduce mechanical damage, supported and fixed correctly, and kept as short as practicable, with a specific allowance for reduced cable size where wiring terminates within a single item of equipment such as a luminaire or single socket outlet. Clause 4.3.3.2, Socket outlets. This clause explains that socket outlets supplied by installation couplers must be suitable for their intended use, securely fixed, installed to meet location requirements, designed to prevent dust or water buildup when mounted on horizontal surfaces, and securely supported where not readily accessible so that no strain is placed on wiring during plug insertion or removal. Clause 4.3.4, Socket outlets in installation wiring. This clause explains that installation wiring must terminate at a suitable socket outlet, with the connection to the equipment continued using a plug and flexible cord or cable. Clause 4.3.5, Other connecting devices. This clause explains that where wiring terminates at a junction box, ceiling rows, or similar connecting device for specific equipment, the wiring from that device to the equipment is considered equipment wiring. Clause 4.3.6, Equipment wiring. This clause explains that equipment wiring must be as short as practicable, have a current carrying capacity suitable for the connected load, be protected against short circuit, include a protective earthing conductor where earthing is required, and be selected and installed so that wiring and connections within luminaires are not damaged by heat or ultraviolet radiation. It also explains that smaller conductors may be used where a proper assessment shows protection requirements are met, and clarifies when wiring associated with pendant socket outlets is considered installation wiring rather than equipment wiring. Clause 4.4 Socket outlets. This clause introduces the requirements for socket outlets, covering their types, where they may be installed, how they are protected, how they are switched, and how they are connected safely within an electrical installation. Clause 4.4.1 Types. This clause introduces the different types of socket outlets that may be used. Clause 4.4.1.1 General. This clause explains that socket outlets must be suitable for their intended use in the location where they are installed, and that they must comply with the relevant recognized standards that apply to the particular socket outlet design. Clause 4.4.1.1.1 Socket outlets application. This clause explains that socket outlets must match the purpose and installation location and must comply with recognized standards such as ASNZS 3112, ASNZS 3123, IEC 60309, or ASNZS 3131, or equivalent standards. Clause 4.4.1.1.2 Socket outlets, alternative pin configurations. This clause explains that socket outlets using alternative pin configurations, such as overseas styles, may only be used under specific conditions. It explains that they must have a single set of pin apertures with an earthing contact and must meet the national standard of the country they represent, and that socket outlets accepting multiple pin configurations are not permitted, except for shaver socket outlets complying with ASNZS 3194. It explains that their installation must meet the general socket outlet location rules, that they must be rated for the installation voltage unless supplied at a lower voltage, and that where they normally supply a lower voltage than the installation, they must actually be supplied at that lower voltage. It also explains that these socket outlets must have been tested to meet equivalent safety requirements to those applied to standard socket outlets. In New Zealand only, this clause explains that these socket outlets are limited to specific locations such as facilities directly associated with international airports or residential areas of non-domestic installations that provide accommodation for international visitors or guests. It also explains that where a nominal 230-volt supply is required, additional protection by an ACD with a maximum rated residual current of 10 mA and by an AFDD is required, and that where a 110-volt supply is required, the socket outlet must be supplied at reduced low voltage. Clause 4.4.1.1.3 Low voltage fixed socket outlet. This clause explains that a low voltage fixed switch or socket outlet, or its faceplate, must not include connection devices for telecommunications, data, television, radio, or similar wiring systems, while allowing USB charging socket outlets on the faceplate. Clause 4.4.1.2 Different systems. This clause explains that where extra low voltage and higher voltage systems exist in the same premises, any socket outlet supplied at extra low voltage must be clearly marked with their voltage and be designed so that an extra low voltage plug cannot be inserted into a socket outlet connected to a higher voltage system. It also explains that socket outlets for SELV and PELV systems must not have an earthing contact and must comply with the relevant clause referenced in this section. Clause 4.4.1.3 Socket outlets for electric vehicle charging. This clause explains that information for the installation and location of socket outlets for electric vehicle charging is provided elsewhere in the standard, and that in New Zealand the detailed requirements are specified in the relevant clause covering electric vehicle charging installations. Clause 4.4.2 Location. This clause introduces requirements for where socket outlets may be installed. Clause 4.4.2.1 Accessibility. This clause explains that socket outlets must be installed so that plugs can be easily inserted and withdrawn without damaging the plug or the flexible cord or cable. It explains that socket outlets must not be installed where a permanent fixture would restrict plug removal, and it also notes that where gas appliances are installed, the means of electrical isolation must remain accessible. Clause 4.4.2.2 Protection of socket outlets. This clause explains that socket outlets must be installed so they are not exposed to undue mechanical stress or damage during normal use. It explains that where socket outlets are installed in floors or horizontal surfaces, they must be arranged to prevent the buildup of dust or water. It explains that where socket outlets are installed close to a floor, they must be positioned so plugs are withdrawn horizontally, unless certain protective design conditions are met. It also explains that socket outlets must be installed so plugs do not loosen or malfunction due to gravity, vibration, or cable weight, and that where socket outlets are not readily accessible and are used for fixed appliances or luminaires, they must be securely fixed to prevent strain on the wiring during plug insertion or removal, with stated exceptions where mechanical stress is already adequately controlled by the wiring system and its support. It further explains that socket outlet use is restricted in damp locations, hazardous areas, and other special situations, and that where socket outlets are installed in fire-rated or acoustic building surfaces, their protective properties must be maintained. Clause 4.4.3 Earthing contacts. This clause explains that every socket outlet must have an earthing contact, except where socket outlets are used for SELV or PELV systems, in which case no earthing contact is permitted. Clause 4.4.4 Switching device. This clause introduces requirements for controlling socket outlets. Clause 4.4.4.1 General. This clause explains that each socket outlet must normally be controlled by its own separate switch that meets the relevant switching standards and operates in all active conductors. It explains that switches controlling socket outlets must comply with the location and marking requirements that follow, and it sets out exceptions where a single switch may control two adjacent socket outlets, where low current socket outlets for fixed appliances or luminaires do not need a switch, or where switching occurs by plug insertion and withdrawal. Clause 4.4.4.2 Rating. This clause explains that a switch controlling a socket outlet must have a current rating that is not less than the rating of the socket outlet it controls, and where one switch controls two socket outlets, the switch rating must be sufficient for the combined or protected circuit current, whichever is lower. Clause 4.4.4.3 Location and marking. This clause explains that the switch controlling a socket outlet must be located as close as practicable to the socket outlet and be clearly identified to show what it controls. It explains that where the switch is remote from the socket outlet, it must be installed in a convenient and accessible position, and both the switch and the socket outlet must be clearly and permanently labeled to show their relationship, with stated exceptions where the socket outlet is high above ground, dedicated to a specific appliance, and not intended for general use. Clause 4.4.4.4 Pendant type socket outlet. This clause explains that where a switch is built into a pendant type socket outlet attached to a flexible cord, the switch must interrupt all live conductors. It also explains that for multi-phase pendant socket outlets, switching only the active conductors is permitted provided the outlet is independently supported. Additional mechanical protection is provided where needed, and the supply cord is suitable for expected movement and vibration. Clause 4.4.5 Polarization and phase sequence. This clause explains that where socket outlets of the same type are installed within an installation, their connection order must be consistent. It also explains that for 3-pin flat-pin socket outlets, the arrangement of earth, active, and neutral must follow the specified clockwise order when viewed from the front of the socket outlet, ensuring correct polarity throughout the installation. Clause 4.5 Lighting equipment and accessories. This clause introduces the requirements for lighting equipment and accessories, focusing on safe location, protection against heat, fire risk, burns, and correct installation to suit the environment and building construction. Clause 4.5.1 Lamp holders, including lamp holders incorporated in a luminaire T. His clause introduces requirements that apply specifically to lamp holders, whether they are separate or built into a luminaire. Clause 4.5.1.1 Location. This clause explains that all lamp holders must be positioned so they are adequately protected from damage that could reasonably be expected during normal use. It explains that for low-voltage lamp holders, their location must reduce the risk of accidental contact with live parts when a lamp is removed and reduce the risk of mechanical damage to the lamp or lamp holder. It explains that this protection can be achieved either by installing the lamp holder at least 1.8 meters above the ground, floor, or platform, or by fitting a suitable guard around the lamp and lamp holder. It also explains that pendant lamp holders must not be installed where they are exposed to significant air movement, such as outdoors or near fans, where movement could affect safe operation. Clause 4.5.1.2 Edison screw lamp holders. This clause explains that every low-voltage Edison screw lamp holder must be connected so that, where a neutral conductor is required, it is connected to the outer contact. It explains that this requirement does not apply where the lamp holder is part of an appliance installed in a permitted manner or where the luminaire and lamp holder include a shroud or skirt that prevents contact with the outer contact. Clause 4.5.1.3 Festoon lighting. This clause explains that festoon lighting must be located and supported so that lamps are kept well clear of flammable materials or structural metalwork and are not within arm's reach of the ground or other places where a person is likely to stand. It explains that festoon lighting may be within arm's reach only when installed immediately below a ceiling. Clause 4.5.2 Lamps and luminaires. This clause introduces requirements for the installation of lamps, luminaires, and associated gear. Clause 4.5.2.1 General. This clause explains that lamps, luminaires, and their associated auxiliary equipment must be installed so they do not cause excessive temperature rise, ignition, or deterioration of materials they are mounted on or materials they illuminate. It explains that luminaires must be suitable for the highest temperatures they are likely to experience from external influences and must be installed in accordance with the manufacturer's instructions, taking into account the highest rated lamp that may be used. The notes explain that some building materials can degrade or even self-ignite after long-term exposure to heat, and that luminaires can generate high temperatures, meaning cables with suitable temperature ratings must be selected. Clause 4.5.2.2 Lamps near flammable materials. This clause explains that where lamps are installed near flammable materials, they must either be suitably shielded so the material cannot be touched, or separated by enough distance so the material does not reach excessive temperature. It explains that where no product information is available, minimum separation distances must be applied, and that flammable shades must not be installed where they could come into contact with any lamp. Clause 4.5.2.3 Recessed luminaires. This clause introduces requirements specific to recessed luminaires. Clause 4.5.2.3.1 General requirements. This clause explains that recessed luminaires and their auxiliary equipment must be installed in a way that prevents excessive temperature rise and reduces the risk of fire from ignition of combustible materials. It explains that this can be achieved by using luminaires certified as suitable for contact with combustible materials or insulation, by installing luminaires with tested and classified barriers, or by providing adequate separation from insulation and combustible materials using clearances or fire-resistant barriers. Clause 4.5.2.3.2 Warning sign. This clause explains that where recessed luminaires are installed in an accessible roof space, a permanent and legible warning sign must be installed near the access point so it is clearly visible to anyone entering the space, and that the sign must contain specific wording and lettering of a minimum size. It explains that this warning sign is not required where all recessed luminaires in that roof space are classified as IC or IC4. Clause 4.5.2.3.3 Installation. This clause explains that recessed luminaires must be installed using luminaires that are correctly designed, certified, and marked, and that manufacturer's instructions must be followed for installation conditions. It explains that in New Zealand, unmarked recessed luminaires must be treated as do not cover types and must be installed using barriers or clearances to prevent contact with materials that could restrict airflow or be damaged by heat. It explains that where insulation is already installed and recessed luminaires are added or altered, care must be taken so safety is not compromised. It explains that bulk thermal insulation can reduce cooling air circulation and that unless the manufacturer permits otherwise or a suitable barrier is provided, space above the luminaire must remain clear. It explains that where insulation is loose, barriers or guards must be used to maintain clearances, that auxiliary equipment operating at high temperature must be installed above insulation unless instructions allow otherwise, that supplied barriers must be installed as part of the luminaire, that higher wattage lamps require stricter installation methods, and that combustible materials must be kept away from hot surfaces to reduce ignition risk over time. Clause 4.5.2.3.4 Classifications of recessed luminaires. This clause explains that recessed luminaires are classified according to recognized classifications that define whether they can be abutted against or covered by normally flammable materials or insulation. It explains the meaning of different classifications and how they relate to excess of insulation or debris to heated parts of the luminaire, and it explains that certain classifications are not permitted in residential installations in New Zealand. Clause 4.5.2.3.5 Requirements for specific classifications. This clause explains that in New Zealand, recessed luminaires permitted in residential installations are limited to specific classifications, and that non-residential installations allow a broader range of classifications. It also explains that certain older classification markings may be treated as equivalent to newer classifications where labeled accordingly. Clause 4.5.2.4 Suspended ceilings. This clause explains that luminaires supported by ceiling panels must not impose loads greater than the panel can safely carry and must not operate at temperatures that would deform, discolor, or otherwise damage the ceiling panel, and it notes that some ceiling systems require additional support or infill panels in accordance with manufacturer information. Clause 4.6 Smoke alarms. This clause explains that national building codes and legislation set rules for how smoke alarms are installed, including where they are located, how many are required, and whether they must be interconnected for alarm purposes. It explains that where mains-powered smoke alarms are installed, they may be connected either to the lighting final subcircuit or to their own individual final subcircuit. The notes explain that connection to the lighting final subcircuit gives a clear indication that the mains supply is available, because a loss of supply would usually be noticed by the lights not operating, and it also explains that smoke alarms are not classed as safety services for the purposes of this standard. Clause 4.7 Cooking appliances. This clause introduces requirements for electrical safety related to cooking appliances. Clause 4.7.1 Switching device. This clause explains that a fixed or stationary cooking appliance with an open cooking surface that uses electric heating must be provided with a switch that operates in all active conductors, and that this switch must be mounted near the appliance in a visible and readily accessible position. It explains that this requirement does not apply to enclosed cooking appliances such as built-in ovens or microwave ovens. In New Zealand only, where an appliance has an open cooking surface that uses both gas and electricity, the switching device must operate in all active conductors. It explains that a single switch may control associated cooking appliances located in the same room. It also explains that the switch must not be mounted on the cooking appliance itself, should normally be within 2 meters of the appliance, must not be positioned so the user has to reach across the open cooking surface, and must not be installed in prohibited locations. It explains that switches must be clearly marked to identify the appliance they control, and that where cooking appliances are installed in public or open areas, the switch may be protected by a lockable cover to prevent vandalism while still allowing operation for maintenance. Clause 4.7.2 Connection, New Zealand only. This clause explains that in New Zealand, a freestanding cooking appliance must be connected to the installation wiring using either a socket outlet or an installation coupler, and it explains that this requirement does not apply to built-in hobs in ovens. Clause 4.7.3 Clearance from open cooking surfaces. This clause explains that socket outlets and switches must not be installed in prohibited locations near open gas or electric cooking surfaces. It explains that this includes areas within 150 millimeters of the edge of the cooking surface, as well as areas directly above the surface up to a range hood, cupboard, ceiling, or 2.5 meters above the floor, whichever is lower. It explains that this requirement does not apply where an appliance complies as a complete unit with an appropriate standard. Clause 4.8. Appliances producing hot water or steam. This clause introduces requirements for appliances that produce hot water or steam. Clause 4.8.1. General. This clause explains that all appliances producing hot water or steam must be protected against overheating in all service conditions, either by design or by installation. It explains that protection must be provided by an appropriate non-self-resetting device that operates independently of the thermostat. Clause 4.8.2. Water heaters. This clause introduces specific requirements for water heaters. Clause 4.8.2.1. Access to easing equipment of pressure relief and terminals of protective devices. This clause explains that every unvented water heater must be installed so that pressure relief easing equipment and the terminals of protective devices are readily accessible for operation, inspection, and adjustment. It explains that an unvented water heater operates at the pressure of the water system, with flow controlled by valves in the outlet system. Clause 4.8.2.2. Protective devices fitted to unvented water heaters. This clause explains that over-temperature cutouts and similar protective devices fitted to unvented water heaters must operate directly in the circuit wiring to the heater elements and must not be arranged to operate through relays or contactors. Clause 4.8.2.3. Isolating switch. This clause explains that every directly connected water heater must be provided with an independent, lockable isolating switch. It explains that this isolating switch must be additional to any automatic switch built into the heater and must be installed adjacent to, but not on, the water heater. It also explains that where a water heater is supplied by more than one final subcircuit, all of those subcircuits must be capable of being isolated by a single isolating switch. Clause 4.9. Room heaters. This clause introduces requirements for permanently connected room heaters. Clause 4.9.1. General. This clause explains that where one or more permanently connected room heaters are installed in a room, each room heater, or each group of room heaters, must be provided with an individual isolating switch and an individual functional switch. It explains that where multiple room heaters in one room are supplied by the same final subcircuit, a single isolating switch may be used for that room. Clause 4.9.2. Isolating switches. This clause explains that isolating switches for room heaters must be installed either immediately adjacent to or within the room where the heater is located, or on the switchboard where the room heater final subcircuit originates. It also explains that isolating switches may be incorporated into temperature control devices, provided they have a definite off position. Clause 4.9.3. Functional switches. This clause explains that functional switches for room heaters must be installed in a readily accessible position in the same room as the heater, or immediately adjacent to the entrance to that room. It explains that a functional switch may be a switch built into the room heater with an off position, or an isolating switch installed in accordance with the requirements for isolating switches. Clause 4.10. Electric heating cables for floors and ceilings and trace heating applications. This clause introduces requirements for electric heating cable systems used in floors, ceilings, and trace heating, with the aim of ensuring safe installation, correct operation, and protection against overheating, fire, and damage. Clause 4.10.1. General. This clause explains that cables used for electric heating in floors, ceilings, and trace heating must be specifically designed for heating purposes and must not be ordinary wiring. It explains that all heating equipment must be installed strictly in accordance with the manufacturer's instructions so the system operates safely and as intended. Clause 4.10.2. Heating cables. This clause explains that heating cables must be installed so they do not come into contact with flammable materials. Where the system is designed to be embedded, the cables must be fully and properly embedded in the material they are intended to heat and must not be damaged by movement, flexing, or shifting of that material over time. It also explains that where heating cables are designed as trace heating, they must be installed so heat is effectively transferred to the surface or material they are attached to. In New Zealand only, This clause explains that in floor and ceiling heating cables must be installed in accordance with NZS 6110. Clause 4.10.3, Isolating switches. This clause explains that heating systems made up of cables or groups of cables must be provided with isolating switch or switches that meet the general isolation requirements of the standard. It explains that isolating switches may be built into temperature control devices, provided there is a definite off position. It explains that isolating switches must be installed either immediately next to an entrance to, or within, the room or area containing the heating system, or on the switchboard where the heating final subcircuit originates. It also explains that where heating cables are used for trace heating, the isolating switch does not have to be located in those specific positions. Clause 4.10.4, Functional switches. This clause explains that heating systems must also be provided with functional switching in accordance with the functional switching requirements of the standard. It explains that functional switches must be installed in a readily accessible position either immediately next to an entrance to, or within, the room or area containing the heating system. It also explains that a functional switch may be the same device as the isolating switch where it meets the required conditions, and that for trace heating applications the location requirements for the functional switch do not apply. Clause 4.10.5, Additional protection. This clause explains that all heating cables must be provided with additional protection by an ASNZS with a rated residual current not exceeding 30 mA. It explains that where heating units have a conductive covering, that covering must be earth. It explains that where underfloor heating units do not have a conductive covering, an earth metallic grid with spacing not exceeding 30 mm must be installed above the heating cable. It also explains that all heating units must be provided with sufficient mechanical protection to prevent damage. Clause 4.10.6, Signs. This clause explains that where heating cables are installed, suitable signs must be provided at each location to draw attention to their presence. It explains that where there is a risk of overheating due to coverings or building materials placed over embedded heating equipment, warning signs must be provided. It explains that this requirement can be met by clearly and permanently marking the functional switch or switches for the heated area, or by providing suitable labeling at the relevant distribution board. Clause 4.11, Electric duct heaters. This clause explains that the electrical parts of electric duct heater installations must comply with the requirements of this standard. It also explains that such installations fall within the scope of other standards and safety requirements, and that compliance may be required by regulatory authorities. Clause 4.12, Electricity converters. This clause introduces requirements for equipment that converts or stabilizes electrical supply. Clause 4.12.1, General. This clause explains that electricity converters include both static and dynamic equipment designed to stabilize voltage, change voltage or frequency, or provide temporary continuous supply when the main supply is interrupted. It explains that examples include UPS systems, semiconductor power converters and inverters, voltage stabilizers, motor generator sets, and rotary converters, and that transformers and engine-driven generating sets complying with ASNZS 3010 are not considered electricity converters. Clause 4.12.2, Selection and installation. This clause explains that guidance for selecting and installing electricity converters is provided in other relevant standards, depending on the type of converter, including UPS systems, semiconductor converters, batteries, and rotating electrical machines. Clause 4.12.3, Control. This clause explains that where an installation is supplied through an electricity converter, the converted supply must be controlled by isolating switching at the converter output or at the switchboard connected to that output. It explains that each converter must have suitable means for starting and stopping, and where more than one control device is used they must be grouped and clearly identified. It explains that converters must be arranged so they cannot energize the installation upstream of the point of connection, except where permitted subject to distributor requirements. It also explains that protection connections must remain intact whenever supply is available from the converter. Clause 4.12.4 Isolation. Clause 4.12.4.1 General. This clause explains that every electricity converter must have an independent isolating switch. It explains that the isolating switch must be located adjacent to or on the converter so the operator can clearly see anyone working on it, must be capable of being secured in the isolated position, must meet motor-related requirements where applicable, must be manually operated, and must not be capable of being overridden by programmable control systems. Clause 4.12.4.2 Electricity converters incorporating batteries. This clause explains that where batteries are part of an electricity converter, a clearly identified switch must be installed next to the batteries to interrupt their supply. It explains that a single switch may be used where it incorporates both AC and DC switching functions. Clause 4.12.5 Overcurrent protection. Clause 4.12.5.1 Electricity converter protection. This clause explains that electricity converters must be provided with overcurrent protection unless interruption of supply would create a greater hazard. It explains that overcurrent devices must be located as close as practicable to the converter output so unprotected conductors are kept as short as possible and do not exceed 15 meters, and that these conductors must be fully enclosed in non-flammable material. It explains that overcurrent protection may be provided internally within the converter or by limiting the converter's ability to supply fault current. It also explains that where converters operate in parallel, circulating harmonic currents must be limited so conductor ratings are not exceeded, and it describes acceptable methods for achieving this. Clause 4.12.5.2 Circuit protection. Clause 4.12.5.2.1 General. This clause explains that every submain or final subcircuit supplied from an electricity converter must be individually protected and must include additional protection where required. Clause 4.12.5.2.2 ASNZS. This clause explains that the waveform of earth fault current from electricity converters can affect ASNZS operation, and that the correct type of ASNZS must be selected. It explains that where an inverter is used, the ASNZS must be suitable for the inverter waveform and installed in accordance with the manufacturer's recommendations. Clause 4.12.6 Earthing. This clause explains that the output of an electricity converter must use the same earthing system as the associated installation. It explains that protective earthing conductors must not be switched and that critical protective connections, including the MEN connection, must remain intact whenever the converter is supplying the installation. Clause 4.12.7 Neutral continuity. This clause explains that electricity converters, particularly static converters such as UPS systems, must be arranged so the neutral conductor to the load is not interrupted during bypass or maintenance switching. Clause 4.12.8 Electrical equipment connected to output. This clause explains that all equipment connected to the output of an electricity converter must be suitable for the voltage, current, and frequency produced by the converter, and it provides notes on conductor ratings, voltage drop, and ASNZS selection for converter-supplied circuits. Clause 4.13 Motors. This clause explains the safety requirements that apply to electric motors, focusing on preventing injury, preventing damage, and ensuring motors can be safely controlled, stopped, isolated, and protected during operation and maintenance. Clause 4.13.1 Protection against injury from mechanical movement. This clause is about protecting people from hazards created by moving parts of motors, such as shafts, fans, belts, and driven equipment, during normal use, stopping, or maintenance. Clause 4.13.1.1 Switching devices. Every motor must be provided with one or more switching devices that can start and stop the motor during normal operation, provide emergency stopping in accordance with Clause 2.3.5. and allow the motor to be isolated for mechanical maintenance in accordance with Clause 2.3.6, so the motor cannot operate while work is being carried out. Where several motors operate together as a group, such as in coordinated systems, one switching device may be used to control more than one motor. A separate switch for isolating the supply is not required where the motor is connected by a plug-in socket outlet, where it is part of an appliance with no exposed moving parts, or where the motor rating does not exceed 150 volt amperes. Reference is made to Clause 2.3 for correct location and function of switching devices, and requirements may exist for motor isolating switches to be capable of being locked in the on position for certain applications. Clause 4.13.1.2, Rating of switches. The isolating switch must have a rating that is not less than the full load current of the motor when installed in the motor supply circuit, or the control circuit current when installed in the motor starter circuit. Where a switch operates directly in the motor supply circuit, it must be capable of safely interrupting the locked rotor or stall current of the motor. Where no manufacturer information is available, the stall current is taken as 8 times the full load current for alternating current motors, or 4 times the full load current for direct current motors. Suitable switches include those complying with ASNZS 3133 or ASNZS 60669.1 and marked with the letter M, switches complying with ASNZS 3947.3 and marked with utilization categories AC23 or BDC23, and switches incorporated with and supplying a socket outlet intended for use with a plug complying with ASNZS 3112. Where one switch isolates more than one motor, it must be capable of interrupting the locked rotor or stall current of the largest motor, together with the full load current of all other motors in the group. Clause 4.13.1.3, Devices for starting and stopping. Devices used for starting and stopping motors must be located so they can be easily operated by the person responsible for the motor. A stopping device or isolating switch must be provided wherever danger is likely to occur due to moving parts. The stopping device must remain effective even if a fault occurs in the motor control circuit. Where motors are remotely controlled, stopping devices must be provided at all points where danger is likely to occur. Emergency stopping arrangements are required to comply with Clause 2.3.5. Clause 4.13.1.4, Protection against restarting or reversal. Where unexpected restarting of a motor could create danger, the motor must be provided with a means to prevent automatic restarting after stopping. This protection is not required where danger is avoided by other suitable measures, such as warnings or guarding. Where safety could be affected by incorrect direction of rotation, suitable measures must be taken to prevent danger caused by reversal of rotation, particularly where reverse current braking is used. Clause 4.13.2, Protection against overload. Each electric motor with a rating exceeding 370 watts must be provided with control equipment that includes protection against overload of the motor. This requirement does not apply to motors that are incorporated into electrical equipment that complies with an appropriate product standard. Clause 4.13.3, Protection against overtemperature. This clause deals with protection to prevent motors from overheating and damaging their windings. Clause 4.13.3.1, General. Electric motors must be provided with overtemperature protective devices where they may be required to run unattended and have a rating greater than 480 volt amperes for shaded pole motors, or greater than 240 volt amperes for other unattended motors, or where they have a rating greater than 2250 watts. Continuously running motors or motors under automatic control in non-domestic premises, where no person is normally present nearby, are considered to be unattended, although consideration may be given where a caretaker or responsible person is present. Examples of unattended motors include motors operating refrigeration in shops, motors located in remote parts of buildings such as drainage sumps, and motors operating communal refrigeration systems. Clause 4.13.3.2, Protection prohibited. Overtemperature protection must not be provided for motors associated with fire protection services, or where opening the motor circuit would itself create a hazard. Overtemperature protection is also not required for unattended submersible pump motors immersed in water where the motor rating does not exceed 2250 watts. Clause 4.13.3.3, Overtemperature protective devices. Over-temperature protection for motor windings must be provided by thermal overload protective devices complying with ASNZS 60947.4.1, or by built-in thermal protection complying with ASNZS 60947.8, or by another device that provides an equivalent level of protection. The protective device must disconnect the appropriate number of supply conductors, being one conductor for single-phase alternating current motors and direct current motors supplied from a two-wire system with one line earthed, and two conductors for three-phase alternating current motors and direct current motors supplied from two unearthed lines. Where automatic reset thermal protection is used for unattended motors, the device must protect the motor windings from excessive temperature under continuous tripping conditions. Clause 4.14, Transformers. This clause explains the installation and safety requirements that apply to transformers used in electrical installations, focusing on correct installation, control, protection, and earthing so that transformers operate safely and do not create electrical or thermal hazards. Clause 4.14.1 General. Transformers must be installed in accordance with clauses 4.14.2 through to 4.14.5. Certain transformers are excluded from these requirements, including instrument transformers, extra-low voltage transformers, luminous discharge tube transformers, and transformers that are incorporated into motor starters or similar electrical equipment. Clause 4.14.2, Secondary Circuit. Clause 4.14.2.1 General. Wiring and electrical equipment connected to the secondary winding of a transformer must comply with the requirements of this standard that apply to extra-low voltage, or high-voltage installations, depending on the nominal voltage of the transformer secondary. Clause 4.14.2.2 Control and Protection. Conductors connected to the secondary windings of a transformer must be treated as submain or final subcircuit conductors as appropriate, and they must be controlled and protected in accordance with the relevant requirements of clauses 2.3 and 2.5. This requirement does not apply where the transformer secondary winding supplies only one submain or one final subcircuit, or where the secondary conductors have a current carrying capacity not less than the rated load current of the transformer primary winding multiplied by the ratio of the primary voltage to the secondary voltage. Clause 4.14.3 Low voltage transformer supply. Clause 4.14.3.1 Isolating transformers. Electrical equipment may be supplied through an isolating transformer in accordance with Clause 7.4. Clause 4.14.3.2 Other transformers. Electrical equipment supplied from transformers other than isolating transformers must be earthed in accordance with Clause 5.4. Earthing is not required on the secondary side where the low-voltage transformer output complies with the requirements of the ASNZS 61558 series. Clause 4.14.4 Autotransformers. An autotransformer must not be used to supply electrical equipment, including circuit wiring, where the voltage rating is less than the highest input or output voltage of the autotransformer. Clause 4.14.5 Step-up transformers. Where a transformer is used to raise the voltage above the supply voltage, no connection is permitted between the primary and secondary windings. An exception is allowed where a connection is made using a protective earthing conductor to provide an earth reference supply. Clause 4.15 Capacitors. This clause explains the safety requirements for the installation, control, protection, and discharge of capacitors, so stored electrical energy does not create a shock or equipment hazard. Clause 4.15.1 General. Capacitors must be installed in accordance with clauses 4.15.2 and 4.15.3. These requirements do not apply to capacitors that are fitted as an integral part of other electrical equipment, such as luminaires, where the capacitor is already covered by the product standard. Clause 4.15.2 Electrical equipment. Clause 4.15.2.1 General. Electrical equipment and wiring used to connect to capacitors must be suitable for the highest voltages, currents, and temperatures that are likely to occur in service. Adequate means must be provided so that heat produced by the capacitor and associated equipment can be safely dissipated. Clause 4.15.2.2 Rating of circuit breakers, switches or contactors. Any circuit breaker, switch, or contactor used to control a capacitor must be suitable for switching capacitors and must have an appropriate rating for the reactive component. An example of a suitable device is a contactor with utilization category AC6B to ASNZS 60947.4.1. Clause 4.15.2.3, Current carrying capacity of supply conductors. Where a capacitor is controlled by a circuit breaker, the conductors supplying the capacitor must have a current carrying capacity not less than the greater of 135% of the rated current of the capacitor, or the setting of the circuit breaker. Where a capacitor is permanently connected to a motor circuit, the conductors must have a current rating not less than the greater of 1/3 of the rating of the motor circuit conductors, or 135% of the rated current of the capacitor. Clause 4.15.3, Provision for discharge and control. Clause 4.15.3.1, General. Capacitors with values greater than 0.5 microfarads must be provided with a discharge path. These capacitors must be controlled using one of the methods described in clauses 4.15.3.2 or 4.15.3.3. After a capacitor has been disconnected from the supply, the voltage between its terminals must reduce to not more than 50 volts within 1 minute for capacitors rated up to and including 650 volts, or within 5 minutes for capacitors rated above 650 volts. Capacitors and electrical equipment containing capacitors must be provided with a warning notice advising that capacitors must be completely discharged before working on the equipment. Clause 4.15.3.2, Capacitors connected in parallel with individual appliances. Where a capacitor is connected in parallel with an individual appliance, it must be connected so that the windings of the appliance provide a permanent discharge path for the capacitor, and no switch or fuse is permitted between the capacitor and the appliance. These requirements do not apply where the capacitor incorporates a permanently connected discharge device. In this arrangement, the capacitor is regarded as being controlled by the control gear of the appliance. Clause 4.15.3.3, Capacitors not connected in parallel with individual appliances. Where a capacitor is not connected in parallel with an individual appliance, it must be controlled by a circuit breaker fitted with an overcurrent release. Provision must be made to discharge the capacitor either by auxiliary contacts of the circuit breaker that automatically connect a discharge device immediately when the capacitor is disconnected from the supply, or by a permanently connected discharge device connected in parallel with the capacitor. Where the capacitor rating does not exceed 100 kV ampere reactive, or where each capacitor in a shunt-connected capacitor bank does not exceed 100 kV ampere reactive, the capacitor may instead be controlled by a quick make and break switch or contactor protected by fuses, provided the switch incorporates a means of manual operation for individual isolation of each capacitor or the capacitor bank as a whole, and a permanently connected discharge device is provided. No fuse or switch is permitted between the auxiliary contacts of the circuit breaker and the discharge device, or between a permanently connected discharge device and the capacitor. Clause 4.16, Electrical equipment containing liquid dielectrics. This clause explains the safety precautions required where electrical equipment contains significant amounts of flammable liquid, such as oil-filled transformers or capacitors, so that burning liquid and combustion products like flame, smoke, or toxic gases do not spread to other parts of the premises. Clause 4.16.1 General. Wherever electrical equipment contains flammable liquid in significant quantity, precautions must be taken to prevent the spread of burning liquid and the products of combustion to other areas of the building or site. Clause 4.16.2 Liquid dielectrics having a flash point not exceeding 250 degrees Celsius. Where equipment is filled with a liquid dielectric with a flash point not exceeding 250 degrees Celsius and the total liquid capacity exceeds 50 liters in any unit or group of adjacent units, measures must be taken to limit the spread of fire, and these measures may include fire-resisting enclosures, dikes, bunds, curb areas, basins, trenches filled with coarse crushed stone, or trapped drains where required, with smaller quantities generally requiring only measures to prevent liquid escape and with consideration given to automatically switching off the supply at the start of a fire. Clause 4.17 Batteries. This clause indicates that information on selecting and installing batteries is provided in ASNZS 3011.1, ASNZS 3011.2, and ASNZS 5139, which should be followed where batteries form part of an electrical installation. Clause 4.18 Gas appliances and equipment. Clause 4.18.1 Gas appliances. Clause 4.18.1.1 General. Any gas appliance connected to an electricity supply must be provided with an electrical means of isolation located adjacent to the appliance and accessible when the appliance is installed, and for cooking appliances the isolation device must not be located in prohibited positions near open cooking surfaces, with appliances that combine gas and electric open cooking surfaces also complying with the requirements for cooking appliances. Clause 4.18.1.3 In New Zealand only. In New Zealand installations, a gas appliance must be provided with a means of electrical isolation using either a plug connected to an accessible switched socket outlet, a plug connected to a socket outlet that may be inaccessible but controlled by a separate accessible switch operating in all active conductors, or an accessible lockable isolating switch operating in all active conductors. Clause 4.18.2 Gas cylinders containing heavier than air gases outdoors. Clause 4.18.2.1 Sources of ignition. Electrical equipment that could act as an ignition source must not be installed within the hazardous areas associated with outdoor gas cylinders, except where equipment is approved or not considered an ignition source under the relevant clauses. Clause 4.18.2.2 Hot particles in surfaces. Exclusion zones in hazardous areas for hot particles and surfaces are determined in accordance with Clause 7.7 and ASNZS 6007.9.14. Clause 4.18.3 Gas cylinders indoors New Zealand only. In New Zealand, indoor compartments provided for gas cylinders must not contain electrical equipment or wiring connections that could act as ignition sources, such as socket outlets, switches, or appliances. Clause 4.18.4 Gas relief vent terminal natural gas, LP gas or biogas. Electrical equipment that could act as an ignition source must not be installed within the hazardous areas associated with gas relief vent terminals, except where equipment complies with the relevant zone requirements. Clause 4.18.5 Reticulated lighter than air gas system, metering system and regulators New Zealand only. In New Zealand domestic installations, only electrical equipment that is directly associated with the gas supply may be installed within the hazardous area associated with reticulated gas regulators. Clause 4.19 Air conditioning and heat pump systems. Air conditioning and heat pump systems that incorporate a compressor must be provided with a lockable isolating switch in accordance with Clause 2.3.2.2, installed adjacent to but not on the unit, and arranged so that all parts of the system, including ancillary equipment, are isolated, with additional isolating and warning arrangements required where internal and external units are supplied separately. Clause 4.20 Lifts. Clause 4.20.1 General. Electrical installations for lifts must comply with this standard and the applicable building code, covering electric lifts, electro-hydraulic lifts, goods lifts, passenger lifts, and motor room-less lifts, with emergency lifts also meeting the additional requirements for safety services. Clause 4.20.2 Lift supply arrangement. Each lift must be supplied by a dedicated circuit to ensure reliable and identifiable electrical supply. Clause 4.20.3 Labeling. Lift circuits must be clearly identified by contrasting coloring or other suitable means so that they are recognizable and not inadvertently switched off. Clause 4.20.4 Motor room-less lifts. Clause 4.20.4.1 General. Motor room-less lifts are lifts designed without a traditional lift motor room, and where installed as emergency lifts they must also comply with the additional safety service requirements. Clause 4.20.4.2 MRL switchboards. Switchboards associated with motor room lifts must not be located in the lift shaft and must be readily accessible where they are remote from the main switchboard. Clause 4.20.4.3 Switchgear. Protective and control devices for motor room lifts must be located in a readily accessible position to allow safe operation, inspection, and maintenance. That now brings us to the end of Section 4. We have covered the key requirements for selecting, installing, protecting, and connecting electrical equipment, including socket outlets, lighting, motors, transformers, capacitors, heating systems, gas-related equipment, and special installations such as lifts. The main message from this section is that electrical equipment must always be suitable for its job, installed correctly, and protected against the conditions it will face during normal operation and fault situations. With Section 4 complete, we are now ready to move on to the next section of the standard.